I picked Prezi because it coincided with the title of this talk, which is sort of obnoxiously boosterish. But the reason I did that is this is about a library I wrote called JMacroPanels, and so I developed some of the concepts while doing at work, in part talking to Ed and talking to Josh Koff, and I think it does something really cool. And I've tried to give a talk about. Oh, by the way, hi, I'm Gershom Bazerman. My name isn't showing up; it's at the bottom of the Prezi thing. I'm still getting mad at Prezi. I'm an organizer with the New York Haskell users group. I work with Ed and Josh and others in S.
Yeah, we tried to get them up here to talk about homotopy type theory, and this is what we got instead.
Yeah, we'll do that another time. So I've tried to talk about this multiple times, and every time I ended up, one time it turned into a talk on adjunctions. So this time I said, I'm going to give a talk that is just about this library that I really want to promote being really cool, and I don't think gets the attention it deserves because I'm bad at promoting, so I'm going to be shamelessly promoting in the course of this.
I guess one thing I can add to that we have mentioned before when we talked about Ermine, we talked about the sort of reporting language that we have for Ermine and all this sort of fancy back-end stuff. So this is...
Some of the core concepts of how we do reporting in Ermine are open sourced in this library, just in only the HTML version of it. It's not about Ermine the language, but it's about sort of functional concepts of web apps. The reason I picked Prezi, for those who don't know, Prezi are big boosters of Haskell and functional programming in general, and they employ the Evan something who does Elm,
yeah,
the language.
They also employ Chalapruska and those other guys.
Yeah, and but this is the first time I've tried to use their app. I can tell they're not using Elm yet, because Elm is a Haskell to JavaScript solution. So I'm sort of in the same space in what I'm going to talk about, but different. And I can tell they're not using Elm yet, because when I was putting this presentation together, it kept telling me that Shockwave Flash had crashed. So, forward to a future where we don't have to worry about that. All right. What scale is the web? What is web scale, man? It was really hard for me to find this out. I Googled around and got some terrible answers. So the slashdot effect in 1999, some guy did metrics. They said, I got 250 hits a minute. I got slashdotted. I found some other more recent numbers. Hacker News front page. Someone did the same thing in 2013. Whatever, dude. Like Facebook circa 2010. Maybe that's not very useful anymore. They said there's 70. I'm sure they're much more now. The UK government said, we posted on budget day. Look how many hits a minute we got. That wanted to look at the UK budget. Then I asked someone here that knows something about dealing with high traffic sites, and they said real slashdotting these days, maybe 1 to 10,000 hits a second. If we have any people actually employees of Akamai here, they can probably tell me what web scale is really supposed to mean when you're like at Akamai scale. So whatever, the point is, I don't want to think about it in terms of this or that number, right? Because the whole point is it's not scale like a particular quantity, it's scalability that we want to talk about. And that's a much easier proposition to talk about. So the whole point is, right, we always talk about scalable applications, this and the other. And, we're programmers. We know exactly what this means. This is big O scaling, right? We want sort of linear, and we also don't want to have to keep it all on one server. We want to be able to, like, scale out, as they say. So we want a program architecture that means that if I have twice as many users, I don't care if I can't handle many users on my server. I'll just, like, spin up twice as many Amazon instances, right? And that's the sort of scalability we're talking about. Is that I can spin up twice as many or 10 times as many or 100 times as many and just linear with the users and so forth. And of course there's obstacles to that. This talk isn't going to cover every obstacle. It's an over-ambitious thing. I'm going to cover one particular difficult pain point. If you have a shared data store that is not your web app itself, but your web app is accessing some shared data store, I'm not going to give you the magic bullet to let that shared data store all of a sudden scale magically. There are other companies that will sell you those magic bullets, and you can subscribe to their services, and they will promise you seamless replication, and maybe they will deliver, maybe they won't. I haven't used them, but I'm not going to tackle that problem. There are other people that claim to tackle that. I'm going to tackle a different problem. But indeed, right, this is why FP must be the solution, is all the bottlenecks we have in all these cases, they all have to do with notions of shared state. So we have the same reason FP is a good solution whenever we talk about concurrency, and of course it's not the magic bullet for concurrency, but you need to adopt FP principles when you move to a concurrent setting because shared memory is evil, you get locking, you have to deal with all of those issues, And eventually you have to talk about algorithms where you pay some constant cost in order to not have to deal with shared memory, in order to not have to deal with locking, and eventually at a certain scale, that is going to win, even though maybe at the smaller scale it will look like you made a terrible decision. That's why we have this push in that direction. We have the same story with the web. We have, and the problem with the web, in fact, we have many different notions of state. You have application state. You have client-side state, right? You know, those of us that have been dealing with the web forever, right? You know, you have like cookies on the client, you have like session, you had to deal with, oh, my session management blew up because I was storing it in the file system because that's what PHP does, and now I have too many inodes and my PHP instance fell over, right? These sorts of things actually happen, right? Or, you know, okay, now I'm going to stick it in the database. Now my database has contention. Okay, so now I'm going to store my state in another, or, you know, now I have two servers. What if the client goes to the wrong server that doesn't have their state, right? And so we actually, you know, they have these solutions for that, right? This is, you know, the clock hash sort of stuff, right, that you'll do. We're like consistent hashing, so every time I, you know, hit it, I'm actually going to like get hashed by my IP so that I'll go to the same guy that'll have my state. He's going to replicate maybe to the next two neighbors so that when my guy falls over, then the next two guys are going to be able to handle it. We have those solutions. People will sell you them. They're pretty neat, but they don't get you to, what don't they do? They're not tackling the problem head on. They're mitigating the problem, right? But now, well, now as this gets bigger, these things get more complicated. People build bigger and bigger tools, all to deal with the problem of shared state. So,
question?
Yeah.
The system that you're going to show us, has it been used at the scale that prompts people to adopt this kind of strategy?
Absolutely not.
Okay.
But please do so. By construction, it cannot have this problem. It can have many other problems. But I promise you, by construction, it cannot have this problem. That is the point, right? We're FP people. We like that. I have type-checked my solution in math. Okay? Right? This is the solution, in a sense, right? If we have a stateless page, we can scale indefinitely. If you want this web page, man, I can give it to 1 billion people if you give me enough servers, right? You know, my limit is the scale of how many servers I can spin up and how many IP addresses you'll give me. So this is a great page. This is where we started. This is not. I should have pulled up Mosaic, not Netscape.
How are you going to direct those users to all those servers?
Yeah, I'm not solving that problem either. You have to have a whole bunch of F5s and probably some like log architecture or something, right? Right, but I'm limited by the scale of how fast you can switch packets, right? That then we're doing pretty good. Right, we're also limited by the scale of atoms in the universe, but let's not. Okay, fine. Right, so this is actually where we've moved towards now a modern application pattern. Well, I'm doing really fast. I maybe shouldn't have, because this is just all very high level. And maybe what we'll do is we'll dig in, depending on how the audience feels, more in the actual code or not. This is all a sales pitch part, and then we'll get as deep as we have time and people want to. So this is why we've moved towards sort of modern JavaScript-y frameworks, which I happen to really not like, but it helps account for it. That because you want a single page app, right? Because that way you don't have to worry about, I load one page, then I load the next page, but the next page depends on the first page, and therefore I have to store the state on the server or serialize it all on the client in a big blob, or, you know. You don't have that if you have a single page app and all the state just lives in JavaScript, not in any cookies. And then the JavaScript goes and makes the requests, and they're just RPC handlers, all right? But, you know, this is really terrible because, like, God, it was bad enough when I had to write, like, database bindings that looked just like my database rows in, like, my OO language that was inflicted on me of choice, like Java or C# or whatever, right? And you've just got this sort of the pattern of the database row and then, you know, the object that looks just like the database row and your object relational manager that has to keep the two in sync and blah, blah, blah. And now you're writing it a third time because you're writing your JavaScript object. Actually, have you guys heard, you guys know POJO, plain old Java object? Do you know that POJO also stands for plain old JavaScript object now? I've read this from people, seriously. Our architecture uses plain old JavaScript object. What other type are there? But so we're just repeating the sins of the past at sort of like an increasing pace here. But it does, in a sense, solve this problem because, you know, and then you still can have all sorts of state problems on the server, but at least in theory, if you have a stateless request architecture, you just set up all of your RPCs on your server with one code base. You set up all of your client with another code base. You teach one how to talk to the other. You cross your fingers. You hope it stays in sync. And okay, that sort of works, all right? Or at least it tends to scale out. And we do have very large applications that run and serve millions of people that do precisely this sort of thing. And they're pretty interactive. They feel pretty good, but they're just sort of miserable. And so, right, this is what I'm talking through here. You have a lot of layers, unmanaged coupling. You're just writing JavaScript all over the place. You're using, I don't know, Ember or this or that or whatever to, you know, try to keep it in order. And it's not. And of course, JavaScript has no namespaces. So, you know, you're creating arbitrary namespaces because by someone wrapping in the closure or something. Right. So now I'm going to be sort of very management consultant-y and propose a law that is probably untrue, but it sounded really good when I wrote it. But I think there's a kernel of truth to it, but as a law, it's just some made-up shit. Right, which is that if you have these two different coupled systems, right, and here's my APIs sort of over here, and here's my other API, and here's my code base that is calling my APIs over here, and they're totally uncoupled, right? But they really should be like growing at the square, like in terms of the area between, because the surface area is what's increasing as you grow one side or the other, and it's just going to turn into a sprawling mess. I mean, it certainly matches with my experience. To empirically verify that, you have to turn these things from intuition-y things into real facts. But anyway, that's the notion.
Wait, so I'm not totally, I'm not following. You're saying, like, the fact that you have to maintain...
I'm saying I have a service
client-side
layer
code
here, and I have client-side code that calls the service layer here.
And
the service layer just keeps growing. Every time I need more shit here, I add more services. The client-side code keeps growing because I keep writing more shit. All of the client-side code is now potentially calling all of the server-side code. And so, like, the entanglement is the square area, is the square of the two, right? Because it's the full area. That's a believable bullshit claim. Okay? Right, as these things go, I think it captures an intuitive truth. It's my experience. I've worked on messy systems. So here's a general solution to that problem, which is a total retreat from our other general solution. We don't write client and server code separately. I know Adam's in the audience. I'm deliberately not talking about Ur-Web because I don't know enough about it, and I expect you're going to tell me that you've done everything that I'm worried about the right way and better, and maybe have even done what I'm going to present, and I didn't know because I haven't worked enough with Ur-Web. So I am withholding all claims on what could be already doing all of this on purpose. And in return, I will hope that you will keep all heckles about how you already all do all this to the end of the talk. So I'm going to mention all the other guys that I know don't get it right and I know a bit more about. But they got a lot of things right. Oxygen is no camel, Seaside isn't small talk. It's no shock, these are all in sort of FP-ish languages. Web blocks and Lisp. The infamous ARC, all right? Paul Graham, that's not, it's really in Scheme. Racket just calls its web server Racket. I think Racket is one of the best ones. Haskell had a very early one called Wash. It's got a more recent project called mflow. These are all varieties of frameworks that use a very functional context because they use continuations. How many people in the room know what a continuation is? Right, everybody. So we all know. How many people know what call CC is? Okay, wow, we got a great audience here. Good. So how many people know how a continuation passing web framework works? About half. All right, so it's a really simple idea, which is why it's been able to be reinvented so often, is, well, I write my program as a client-side program. Every time it needs some interaction from the user, it just captures all the possible state, it captures what it wants to do next, based on if the user were to interact with it. It's gonna it captures that as a continuation. It calls call CC. Now, it has to, in the traditional way, it's going to associate that with knowing who the user is. So it's going to use basically the same sort of notion of a session, right? But your session stores on the server side in memory. It can store whatever you want. You store the continuation in the session. And then you give back the web page, and then whatever button they click or response they have then gets fed back into the continuation as the rest of the program. And so now you can write something that looks like a normal, you've re-inverted control, as they say, using continuations. That's what continuations are good for, is inverting and re-inverting control. So you write a very traditional imperative-looking program. Ask the user for their name. then give back the page that says hello name, and you don't have to write many different web pages. It's all done with continuation. It's beautiful. It's got a lot of problems. Some of these frameworks solve about half of these problems. So let's talk about... this was before ARC was released, but I love this meme so much. Now that he's released it, it's not as funny, but I just wanted to call back to it. But yeah, the main problem is if you're doing it the old way, right? Every time, and you still get this on like Hacker News and stuff, every time I click something and there's nothing dynamic, it actually just takes me to a whole new page. If you look at the links on Hacker News, maybe they rewrote it a bit since I last checked, they're just a number. Why is that? Every number is tied to a different continuation in memory on the server. What happens when you get way too many users? Well, the server just starts garbage collecting continuations. So depending on how many users Hacker News has, the links you've loaded in your page will expire and become completely useless in a span of either, days to weeks to hours. It really just depends on how much memory pressure it's feeling at every given moment. So there's some very bad things about continuations, even though that model is very elegant. And of course, it's the opposite of scalable, because they're all living in memory on one server. You can't even ship it to another server necessarily, because it's just an in-memory control structure. It's code in memory that you've just stuck in your session state. All right. Going back here, because I'm not going to go into it later, I don't have enough time. There's some really good research that solves about half of these problems in a number of these. And the racket one is the case I'm the most familiar with in this regard. And so they've done work on what they call continuation marks, and they have serializable continuations. I will claim it's very nice, but it's still sort of ugly when you get into the guts of it, and it doesn't fully solve these problems, but it ameliorates them a lot. And it does that in a way that's almost similar to some of what I'm going to present. But that has significant difference. I can't go into a full accounting of the differences, and then some of them, I don't know which ones are a bit more Ajax-y, and they will say the continuation doesn't have to just load a whole new page, but can maybe deal with an interactive portion of a page. But I don't really know the state of the art on that, and it certainly used to be the case. None of them were like that at all. Okay. Here's my proposal in some sense. We mash up these two solutions. We want to write code in this continuation passing style. It's the nicest, most elegant style I know of in a certain sense, right? And maybe even in a slightly nicer version of that. But capture that notion of whenever you write a single program, you don't have different pages, you don't have callbacks that you have to follow. You just can say when you want input, find me the input, and then keep writing the whole program in one fell swoop. So you want to write in that style. You want to write as a real program. But you also want to write client and server code that has this sort of jungle, like in what you interpret it into. It's still going to be this jungle of callbacks and stuff that's very stateless, very efficient, ideally stores nothing on the server, but also doesn't just, like, the other thing, this is a terrible thing called the infernal machine in PHP that did continuation patching style, and was hilarious. It actually captured the continuation in PHP through, I don't know, deep black magic. Like, it just, like, called back into, like, wherever the location in memory it was supposed to be. It extracted the code out, it hex encoded it, and it sent it back to the browser. So that was beautiful. This is stateless. This is everything I'm talking about. Except it's deep black magic, like, sort of, so you don't want the user to actually have so much access that I've stored my continuation as code that I'm going to directly interpret as bytecode back on my server, right? You don't want to let the user run untrusted code on your server because you're asking them to keep track of your continuation at that level.
Please don't mess with this code. It's important.
But it was beautiful. So one should also take inspiration from it as well as fear. All right. So this is what I have. I have this thing called JMacro RPC panels. It's a terrible name. I'll explain what JMacro is, and then I basically just call it panels, and it just happens to live in this thing called JMacro RPC. And I'll talk about what JMacro is a bit too later. But I'm going to talk about how we mash these two things up, get the benefits of continuation passing frameworks without the drawbacks of them. And therefore, by construction, we scale arbitrarily. Because we have no server-side state, you can hit any server you want. You can bring the server down and up again in between, right? As long as your F5 can, like, sort of, route it to a server, it doesn't matter which one it hits by construction. Okay? There might be other efficiency issues with it, but it cannot have that. The core notion here is we're not just building up, what we want to do is we want to build up HTML, right? That's what's got to go to the client. We want to build up, though, not just HTML and JavaScript together, right? Maybe I should, instead of calling it page slice, I could have been more marketing, and I could have called it active HTML. HTML that says how it acts, because that's the real world we live in, right? With web pages these days, is you have components that you assemble, and they each have actions attached to them and shit. They're not just these plain old components. So you need to do that. Then what we do is we have panels. And what a panel is it's two types of HTML. PM is just our monad that carries an environment that we're going to be sort of hand-waving about, because it's really implementation details we could drill into for what that environment is. Suffice to say that you can reconstruct that environment. Maybe you have I/O in it if you want to talk to a database or something, but everything else in the environment is going to be passed in the request from the client, so it's not going to require any other server-side storage. And then you're in your monad, and you can either create just some active HTML page slice, or if you run in a different context, you're simultaneously building up two different things. You're building up what you might want to display to the user, or if the user does something, how you might need to update in response to whatever that thing they do is. So that's panel IDs and page slices that are associated together. And it's an action, because it's in a monad. So this is an action that might do I/O, might do whatever I want to generate some HTML. There's another action that, in my context of what I know about the page, can give me back a potentially empty list of things I might need to do in order to update the state of the page, such that everything else, yeah.
So is the idea that when a panel ID is selected, you replace the page completely with...
No. The idea is this is an update list. This goes back to the client. The panel IDs are associated with different divs in the page. And this list, when it comes back to the client, will then say, oh, the server says that number 503 should be swapped out for this other bit of HTML, and then I should run this other bit of JavaScript to make that HTML dynamic again. And that's potentially empty. And it's efficient in that we track a dependency graph behind the scenes so that I just return back, don't update anything, and I don't even need to traverse and ask everything if it needs to be updated because I propagate the dependency tree information up. And not only up, and again, not all this on the slides because it's hard to figure out how to make, we can do the deep dive on the code, it actually gets resolved on the client side. So we don't even build the dependency graph on the server side. We build the dependency graph dynamically on the client side, but we declare the dependency on the server side. And that actually turned out, when I was writing this, to make a huge difference. Because I can build it up with mutable state really easily on the client side, and I can just, which is fine, because I'm just building a structure up once and for all. And then on the server side, when I declare it, I don't have to worry about sort of threading it through anywhere. Because it turns out you never use it on the server, as long as the client keeps track of the dependencies properly. The server just has to respond to them. All right. So our core interface here, it's not applicative, it's not monadic, it's none of these fancy things. It's a monolith. Why? Because HTML is a monolith, right? What do? It's I have this, and then I stick it next to that. It's a text file, right? Or an XML file that at the top level has a bunch of DOM nodes, and we just shove them one on top of each other. Now, obviously, you can nest them and shit too, and we have some combinators for that. But the core thing that's going on is monoidal, okay? And then this is how we do nesting, is because panels have HTML inside of them, we can sort of map HTML to HTML. Any transform on HTML can be done as a transform on the panel. And that includes now taking a bunch of HTML, concatenating it together, then wrapping it in another tag for a div or a table that encompasses it all. So we get to keep all our nice semantics of HTML. And it's like we're writing with an HTML combinator library, except we also get all of this action tracking for free.
So I think you probably said this, but what is PM conceptually?
Conceptually, it's the magic information the client gave back to you that tells you about the things in the state of the client that you want to know, and none of the things you don't.
Okay.
And then it also is probably a transformer over something like I/O if you want to talk to a database or whatever else.
Mm.
I could, if we want, I can just pop up with the code editor and we can talk about code directly. It might be a bit easier. It's sort of ugly looking, so I didn't feel like presenting it as part of the sales pitch part. There's some real ugly looking stuff inside, but a very nice interface that we'll talk about. All right. So I said we're a monolith. Our target semantics is a monolith. Our signal semantics are applicative. So what a signal is something you can read from a client. This is very FRP-like terminology. I'm not going to go into a relationship with FRP or not, or if it's there or not. Or maybe a little later, but not now. Yeah.
Are we going to get to an example of the types and values on the previous slide? Or was that supposed to be a self-contained explanation of how we would actually use this?
No. I'll show you some code samples. I'll run some actual code.
Okay.
I got everything compiling. I'll give some demos. Afterwards, we can do some live coding if you want to see if I handle things right or do something fancy. My examples are ugly, but they show complicated interactions. Or at least tricky, maybe not complicated. So a signal is just something that has a value inside. I left out the constraint. It's got to be serializable. I tend to use ASIN and JSON everywhere, right? So, because these are things that are going to come from the client. So obviously, it's got to be able to come over the wire as some sort of string. But it's basically applicative. And so it doesn't have to start, but because when it comes from the client, it has to be deserializable. But then you can have an intermediate value, right? Because signals are just anything from your surrounding environment, but you can transform it. So you can map it, you can, it's applicative, you can have a function inside of it and apply it to another function. It just so happens that's what it is. Events we describe fully as monoliths. They're just things that can happen. And if I have one thing that can happen in another, it's OR. So the monolith is OR on events. And we can track events that happen on the client. So an event is like I click a button. A signal is like, I've selected a value from a dropdown. So that's value from the dropdown I can sample continuously, right? At any point in time, it has a value. Events are discrete point in time. A sync is really just this. It's just A to pound. This is everything a sync can do. We just wrap it up as a sync instead. And so it's a contravariant functor, trivially. The reason that we actually declare it separately, I'm glossing over. There's some slight ugliness that lets you be more efficient because not everything has to go back to the client. If you do stuff that would have to go back to the server, if you can do some stuff purely within JavaScript and never make the round trip to the server at all. And then you have to be a bit more limited in like what can actually be inside a sync and a signal and stuff. So that's why a sync isn't just a function A to pound. It's actually got a little tag that tells you if it's a sync that is that you can treat as something that you're going to manipulate in Haskell, or that is only going to get read in JavaScript, right? Because you can't be an instance of contravariance and be purely in JavaScript, right? Because coef map is going to map an arbitrary Haskell function over contravariance, so you can't do that. You can't take every arbitrary Haskell function and send it to JavaScript. Although there are projects that do that too. So. So reading signals now takes a continuation. So what I like about this is none of this is artificial. It's not like I said, oh, it must be this type, and you know what a cool type class is? Applicative, and then I made this thing applicative. You just write this out, and you naturally see a structure where you have monoids, you have applicatives, you have contravariant functors, and you have these continuations. Because when you sample a signal, you're not actually doing anything yet. You pass in the continuation of how to build the output. And then so you have this continuation passing style looking thing. This is select. This creates a select dropdown, for example. Is I'm going to give you a list of strings that are the names of things in my dropdown. A is the values associated with them. It's an association list. I'm going to give you. You're going to give me a continuation. So.
Why didn't you use sync A at the top?
Because it's not a sync. It could be. Syncs have a special meaning.
Okay.
The problem with syncs is they do something magic, which screws up my semantics, but I use it for other reasons, so I'll get to that later. But yeah, but outside of that, so that's why I didn't call that sync. Okay. I was thinking about the fact that they're unified types, and it might be fun to unify them. But syncs are like those guys, except they do some magic stuff, that's why.
Okay. And
these don't. These are totally normal. So we don't want to talk about syncs if we want to talk about its deterministic semantics, and I'll get to that. You give me the list of things that that you want someone to be able to select from, and then you give me a continuation that says, well, here's an event I can listen for, And here's the signal, right? So this event is going to fire every time this dropdown changes. This signal is going to be whatever the value of this dropdown is whenever I read that dropdown. Whether or not the event fired, I can always read the signal. And then you're going to give me, and then you're also going to take. So I'm going to give you the event, the signal, and also the panel, which is the thing that actually contains the dropdown, so you can put it somewhere physically on the page, right? And then you're going to give me back a panel, right? That's what the function does. It just assembles a page out of all of these different components. And then that M is an artifact that I didn't take out, yeah.
Should we think of this continuation as being called once or on every change of the select?
The continuation doesn't get called once or on every change of the select. It gets called when it needs to be called. Now, now let me make that a bit more clear. It gets called when something that it relies on gets updated. Or when you explicitly, if you're listening for an event, then I can say on event. I have a combinator on event. So this gets rendered once at the start. Now, if you don't listen for any events or react to any signals, it'll never get called again. If you call with sample, then with sample will get called. Not even every time this changes, because we have events, we have change events. It gets called every time an event it depends upon changes. So the only thing that can fire off something happening is if you read an event. So if there's an on-event call, that'll say, when there's an event, update yourself. And you need both behaviors, because sometimes I want to change like 12 selects and then click go, and then something happens. Sometimes every single select I want to change, I want to immediately see the results on the page. You need to be able to capture both behaviors, and that's what happens here. Is it gets called explicitly with an event that says update yourself happens, and only then.
So with sample, doesn't take an event that says, is that just going to be called once?
It gets called whenever it needs to be by the on event. I didn't put the on event call here, which on event is just event arrow, panel arrow panel.
Where do you get an event from?
Events come out of, for example, they come out of a select where I have an event here that I can listen for that happens anytime a select changes. I have a button combinator somewhere else, and when I call button, right, the continuation gets handed an event and a panel. The panel is like just the HTML that contains the button, and the event is the thing that gets fired whenever the button's clicked.
So being like some outer scope would give you an event.
Precisely.
And then you would.
Yeah.
We used to have event and signal tooled up as like an observable type or something like that. You might remember from way back.
Yeah, in our internal code, we did something horrible back in the way, Paul, which is that we wrote a version of these semantics, but where the target semantics was not HTML, but it was JavaFX. So instead of this sort of continuation passing model, you had a model built around observables, which is cute when you're just in the JV app. But how do I listen to an observable when I'm on a web page? A Java observable. Sorry. So we ripped that out and replaced it with this. Okay, so here, how many people speak abstract nonsense in the audience? Oh, that's pretty good. Okay, so this is an idea I had today, which I won't dwell on, but one wants to give a definite semantics to this stuff. The fact that we have an applicative, and we just and then we have sort of this continuation thing over it, it basically suggests that you have sort of a natural pre-sheaf model that's going on here. And that's what this should look like. So I'm going to run through this quickly. We can talk about it later so I don't lose the rest of the audience. This is totally speculative, but basically, right, you have a collection of functions of type A arrow pattern, right? You can think of them as sync functions or something. Morphisms between them, they're contravariant, they're by opposite morphisms in Haskell, right? It's a continuation. So you've got sort of a UNATA slice category story, and that should give you your semantics. So it should be Haskell valued pre-sheaf, then we have a collection of functors. Every time we introduce a new signal we're going to listen on, there's going to be some analogy to like weakening if you do like categorical semantics, right? And then you get the monad, the continuation monad built out of that. And from that adjoint, I'm sorry for the rest of you, I'm going to get through this quick. And I think that basically should let us give a simple categorical semantics to the entire thing that looks a bit like an incremental lambda calculus. So we have a good story there until you introduce the evil that syncs to. So this is why syncs are evil, is you can do this. I can bind signal to sync. So every time an event fires, we're going to take the signal and give it to the sync. And then what the sync is going to do is, in theory, that's going to be something that just can do any arbitrary thing on the page, including giving it to another, creating another signal. So now I can introduce loops. The reason I did this is I really needed loops, because if you have this, and if you can produce a sync and signal pair that are tied together, right? And Hudak calls them like black holes and white holes because they give you spooky action at a distance inside of your whatever your reactive semantics are. Then you can create MVARs. So now I have top-level mutable state. And now I can't give it a nice semantics anymore because like I've got full imperative programming now. And that's what syncs are used for, is pure evil. So here is, again, utter speculation for those in the audience who might care. There's a fellow by the name of Jay Sulzberger in New York, and he keeps explaining this project he's working on. So I call it Sulzberger's hunch, which is in a wide category of different topoi. You sort of get this property that if you say there's no cycles, it's very easy to describe. If you say there's arbitrary cycles, it blows up in your face. You have no idea how to describe it. But if you look at sort of the graph and get a characteristic polynomial of it in sort of an algebraic geometry sense, I don't understand this stuff fully, and then you look for a degeneracy condition, you can find some other rule that says we can give it a good semantics if the polynomial is not degenerate in a certain fashion. And I think that has to be the case here. So that's future research for anyone that wants to do it, is that you should be able to give semantics even with strange loops, as long as you can run some checking function to make sure that you don't have sort of degenerate feedback conditions. All right, now back to the real world. Okay, so this is why it must scale. All state is in the browser. Requests only send the necessary state to reconstruct the path, right? So you don't traverse every part of the tree, only the parts of the tree you need to. Updates only update the dependent portions. So therefore, if I need to reach twice as many people, I can have twice as many servers, and it cannot be the case that there's any problem with that. And yeah, of course, updates have to scale. There's all the other problems with that, but there's not that one problem with that. And also, you know, as you build out more and more code, you have all these functional abstractions at your fingertips. You've just got these completely reusable monoidal block components you can append, right? So you don't have any weird coupling there. You don't have to build out services separately, so forth. So I claim it works very well in all these regards. We have evidence from our code base at work that it works very well in this regard. We don't have enough users to make this claim. But we have seen it do the right thing when requests get routed randomly to different places, which we do. It never breaks, so we know it handles that. Okay. I said upgrade seamlessly, and I just made this slide because I said that in the title. I'm sorry. I didn't really get to it. I'm not going to dwell on it. All right, and that's... I had another slide that I forgot to link into this Zoomy Prezi thing. Did I? Somewhere around here. And then we can talk some code. No, I had that slide already. Come back. Come back. Ah, I had two more slides I forgot to link in. Oh, this is, yeah, no, just this one. So I want to talk about the JMacro library as a whole, how this stuff got built on top of it, and then we can talk about some code and run some examples, maybe some questions. So JMacro started out, it has the word macro in its name. It was a macro library. I was writing a lot of Haskell, and I needed to start writing JavaScript, and I hated writing JavaScript. So we wrote a DSL for JavaScript in Haskell, and then it was sort of ugly because, you know, it was just you were writing the raw AST in Haskell, and that's sort of ugly. So we wrote a quasi-quoter on top of that. So now we wrote stuff that looked a lot like JavaScript, quasi-quoted in Haskell, and we could programmatically generate it, which was cute. And on top of that, we gave it a syntax so that you could write raw JavaScript and it would turn it into the right AST. And you could also write JavaScript that looked a lot more like OCaml, and it turns that into the right AST too. So it's, which is very nice, and I can show some examples of that. So now you can write code that looks like OCaml in Haskell, but is actually JavaScript, and it's quasi-quoted, and there's anti-quotes. So inside this stuff, I can then inject other Haskell that generates JavaScript and expand those macros inside of it. So I can anti-quote just like I would in Lisp. You can't anti-quote, but that's okay. And that's pretty fun. And on top of that, Right? It's got a syntax checker. It'll check for correctness. It'll check that your regex are real too while it's at it. It'll implement hygiene so that it does unique naming. It gives you better scoping rules than JavaScript, which are atrocious. On top of that, we built client and server implementations of JSON RPC and stateful per page invocation sort of interops. So, yeah.
Is it a desirable feature to have to write this code in a different language than when you write the rest of the application in?
This stuff? At the time I did it, yes. And I'll tell you why.
Okay.
Is I like to use a lot of JavaScript libraries from all over the web, written by people that wrote very good libraries but have ridiculous taste in how to write libraries. And they're going to use every like object-oriented idiom on the planet. But if I obey their rules, now I've got like this gorgeous tree visualization. I didn't have to write a line of code, right? Or even if I want to manipulate the DOM, I want to use jQuery. You can type jQuery, but it's really hard because, like, if I pass it a string that has HTML in it, it gives me back HTML. If I pass it right, if I pass it something else, it'll give me back something else entirely. If I pass it a function, it'll run that function the first time the page is loaded. It's super untyped. And right, jQuery is not a monad, in case you thought it might be. And one of the reasons it's not is its map function, which it claims to mean functional map, is in fact flat map. Sometimes, right? If I map over something such that I get back a list of, each element turns into a list, it'll concat them all together, and I'll just get one list back. If I map back such that each element doesn't turn into a list, it won't concat them together.
Ew.
Yes! So, okay, have fun, but it's a gorgeous library. I couldn't live without it when I do web programming, right? So I wanted something that would let me use all the evil libraries in as nice a way as possible without having to take each one and wrap it up in an FFI and so forth. So that's why this is at that blue layer. This is also a great library for other people that want to write better languages and compile them to JavaScript as an intermediate layer. So I mentioned compiling Haskell to JavaScript. The most complete version of this is a compiler called GHCJS. How many people know GHCJS? Right, so the entire backend for GHCJS now uses JMacro, all right? So he uses it to generate the JavaScript in a nicer way. It lets him talk about application, all these nice things, generate a gorgeous syntax tree, without having to, while sort of writing in an idiom that's closer to the target language.
I think he technically had to inline all of JMacro and GHCJS. There was something else he was doing.
So he killed that again?
Yeah.
He was using it for a while, and if he got off it, he didn't tell me. He gave me a lot of pull requests, so I knew he was using it now.
Yeah, he mentioned it to me like Tuesday.
Don't spread a dirty rumor.
So it's more recent than that.
All right. So anyway, for a long time it was, and I don't know. Maybe he's had to get rid of that for other reasons. But I know nothing of that. Anyway, so this is JMacro, and then I built some RPC stuff on top of it. And this was very stateful, and it worked for the use cases we had. And you still have that, and it's nice. And also, if you want a JSON RPC implementation, it's right there. And anyway. Right.
So what is what's the server that's used?
It's got multiple backends. So it's really pluggable. It's designed that way. It's got Snap and Hapstack backends both at the moment. Warp was too much of a moving target. I got sick of writing backends for it. That would then, and then they rip up the entire API. And so I was like, if this gets some traction, maybe someone else can do that. But I'm sick of tracking the changes. In fact, this is the Snap backend, which I actually brought up to show there's 1, 2, 3, 4. Ignore the page the type signatures, the imports and share. There's 1, 2, 3, 4, 5, 6, 7, 8 lines is all the adapter takes because it uses this pattern where, right, you just take the function that does the thing, and then you just and you plug it in. So it's sort of poor man's polymorphism, like dictionary passing polymorphism. But it'll let me write it, and similarly, Hapstack, there's only about maybe 4 to 6 lines of actual code in the entire bindings that take the generic package and attach it to the backend. Basically the function that says, here's how to handle a put request, here's how to handle a get request, here's how to take HTML and give it back to the user. You just pass them into the generic package and it'll hook up to each backend. So that's something we can, we can talk about the types of JMacro RPC, we can run some demos, we can do both. So here's demo 1. Let's do demo 2 first, it's a bit easier. So this is not very exciting. So I choose this drop down, and it changes the two guys below it, like immediately, right? I change this guy. Nothing happens. What happens? It broke it down. It has to wait for the change event on that, and then it changes. So very exciting demo, dynamic web page, dude. But it's a dynamic web page.
What exactly is the back and forth over the wire?
I was about to show you, but I need to pull up my. God damn it. I hate it when this happens. So, what happens is if Chrome is not in the same screen that you started it in, then it gets very confused when you try to open up an associated page. There we go. So let's look at the network. I guess there's some trace locking in the here. All right, so nothing's been happened so far. I just loaded up the web page, right? No communication with the server. I'm going to change this to that. There's a post. Come back, network. The post has said there's an update event, and here's the parameters we're sending, which are the values of the selectors on the page that we could possibly be depending on.
Could you make that a lot bigger?
At the moment, it sends a bit more information than it needs to, and you could perform some obvious path compression on the auto-generated names, and get so that they don't get really long, and it would and that would solve that problem. At the moment, we haven't bothered to do that, but we know how to, so it's not interesting. Yeah.
Does it make sense to contact the server on that particular UI interaction?
Because I wanted to show it talking to the server. You could also have it not contact this. Or in fact, in the case of this too, the reason it contacts the server is everything that generates new HTML contacts the server, because we assume you could generate arbitrary HTML. Like if you wanted to write a special component that did something else, you could do that, but at the moment all the HTML generation only happens on the server side.
That sounds like a consequence of of not taking code written in one language and making it run in the browser as necessary.
It sounds to me like you have a solution to that. that maybe you want to tell us about. No, we could solve this problem without doing that, actually, because of the way this is written. You don't need to actually write all the code in JavaScript. You could do abstract. There's plenty of ways to do abstract interpretation of the simple stuff. It's just a use case we haven't cared enough about, because sending a message to the server that gives back a little code or a little code HTML isn't going to kill you. Now you might argue, well, it'll give you an order of magnitude improvement if you have an order of magnitude more users that are doing this shit all the time, and you're right. But who cares? I can scale out arbitrarily. So, not right. I'll just spin up another server. Money's cheap. All right. So, right. That's my claim. Is this, for the purposes of this talk. So it's sending the information about the settings that we might be interested in. It might be sending more information than it should at the moment, but I can fix that. It's a bit, so it sends some information and that happens. Now let's look what happens at the next thing. I choose this guy. Huh?
What was the response?
Oh, yeah. So let's look at the response there. The result here is it says there's a panel with the ID 1_0. Right? So the thing about these IDs is that they're a tree. Right? There's a lot of ones and zeros because it's sort of a deep tree, but not very wide at the moment because it's a very boring page, right? But all the things that are next to each other, they go out. So that way, if I swap this guy on this side, then this guy over here, his ID doesn't change because all the IDs generated under that guy, the tree doesn't correspond to the DOM tree, by the way. It corresponds to the dependency tree. But that way, if I swap out one section of the page and it turns into something entirely different because all the dependencies changed, right? Because its dependency changed, then the IDs over here don't get affected. So the fact that we don't replace them doesn't screw things up. And that's what lets us do sort of opportunistic local replacement instead of the entire page. Then it actually just sends back the HTML. It says, well, here's a div. It's going to have this ID and this name. Here's another div. And here's all the other stuff we're going to splice into the page. And here's the JavaScript to run there. So it just swaps out everything underneath. Now I change this guy and I click the click me button. It sends a lot more information because there's more dependencies.
Could you possibly show the code that you have? Because so far you've shown the interface. And
Yeah. Well, let me get through this, then I'll swap to
I
that.
have no idea what your library is doing because you haven't actually shown us how.
No. This is what it is doing. Literally, you don't know how I'm telling it to do it. The opposite problem. And here you can see it's only sending back much less information because it's only sending back just that portion of the page that says you chose and nothing else. And then also the dependencies that all this thing happens to depend on. So you want to see the Haskell code that generates that example. It's right here. Although maybe let's use this version of it. God, why is this? The revolt of the inanimate objects. That's the wrong one. Sure. It's this. So it's a selector. Huh? Bigger?
Yes.
Big enough?
Yeah.
Right. So this is saying we're going to create a selector. It's going to let you choose default or another. Default is going to give you back the number 1. Another is going to give you back the number 2. And it takes a continuation, which is all the page underneath the selector. So given the event that the selector generates, the signal that tells you how to read out of that selector, and the panel that contains the actual selector that you're going to stick somewhere on the page, we're going to display the panel, and then we're going to append to that the HTML generated by saying whenever the event fires, so whenever the selector changed, then we're going to sample the signal, read out of the selector whatever that value is, and based on whatever that value is, the choice so made, we're going to create another selector that is going to have that choice again there. And there's the default value, and then we'll have the 2 choices of either that choice plus 1. This is a bit stupid, but anyway, right. So if I chose 1, it'll show me 1, 2. If I chose 2, it'll show me 2, 3. Yeah.
So it was the type of select in your slides simplified?
Yeah. Here we take a default value and then the rest of the list. So I could use a non-empty list for this as well.
Okay.
But I'm not doing that. Yeah.
If I tamper with the post request, how will this fail?
Probably a million ways. The worst thing that'll happen is you'll go down a different code path here, or you'll just get an error that says you sent me nonsense. Right? It's not arbitrary bytecode. It's just sending back the values that are traversing this tree. Yeah.
Do you support any kind of bookmarking pages within an application?
In this model, not directly, no. You can build that sort of thing, but it's got to be orthogonal to this. You can build on top of this, but this, and I've done that in the past, but you can't do it directly with this. Oh, there's a cool notion here. You can reconstruct the entire state of the page from the environment, right? That's what this tells you. So even if I only am updating some things that changed, if I have the full environment, that's enough to give me the full page. So I have some notion of like the permanent snapshot. That's the program execution trace to get me to this precise configuration. I just haven't written any particular way to then capture and serialize that anywhere useful because it hasn't occurred to me that there's one particularly good use case. But it would actually be very easy to build that on top. And
if we actually start talking about when we use this with other backends and our other side, we can say, take this snapshot and then send it off to Excel or send it off to a PDF or whatever.
And
so
we actually have a model in one of these
back.
backends. We have a model where one of our syncs doesn't feed back into the page, but it's just a dumb sync that just sits there. And then we actually serialize the state of that sync. And then every time you reload, it'll deserialize that sync, give you an input through it, so into the top of it. And that way you have persistent option settings that stick around and get associated with different widgets that you manipulate on the page. And we use this sort of notion for that, actually. So you can snapshot state very granularly and sort of on an opportunistic basis. It's not all or nothing. And we have use cases for that. We, in theory, have a use case where we're going to capture whatever the settings you have and then hit another backend, like Excel, with precisely those drop-downs picked. But we haven't built that. We probably won't build it anytime soon. But right, because right at the moment I'm only generating HTML. This panel happens to be HTML. But I can stick any monoid in there that has a visual semantics. So I got right, and everything else remains the same. So you can this generalizes to very polymorphic things. It just so happens this code is written that way. And then there's the button, right? That reads out so that this guy takes another event that's more signals. And now we have a button, and you click the button. We have a button event. And then we're going to display the second selector and then the button, and then a line break, right? So I'm just lifting, this is BR from, whatever the Blaze markup library is, whatever I'm using. And then I say on event here. So whenever this event fires, the button event, then I'm going to read the second signal, but only then am I going to read it and then show the result of both the first and the second signal. So that sort of captures that logic there. Yeah.
What happens if you want to build some kind of GUI widget that gives you a handle to the widget you've produced? The way you have, for instance, select set up, you get to pass a continuation that returns a panel. But what if you want some other output, like a value that stands for the widget you've created?
Oh, you can pass that out too, but then you've got to have another continuation there. You're in a continuation monad. So if you write in a monadic style, you immediately see, right? It's continuations all the way down, but as long as at the very end of the day you get out the panel, you can have as many arbitrary things as you want in between. Right, but that's just telling you, right, just like the function main in Haskell has to have a type IO. But all my other functions can have any other signature. That's sort of the same rule here. Right? I can't have a function and say, okay, now display it. I got to make sure it's a pattern. So now let's do a slightly more fun example that actually shows not making a round trip. And it shows, this is your typical hello world for a functional reactive, is a calculator. Pardon?
It's just your comment. This is bad. You ought to fix this in the log.
Oh, that's not my comment. That's Snap's. Because it can't open error.log because I'm just running a demo Snap server, so it's not configured. All right, so let's open developer tools for this. Is that popping back in? Yeah. All right, cool. 5 plus 8. 13. I always wondered what that was. Times 2. It's a supercomputer. All right. Now, you'll notice it actually only called back to the server twice. And the reason it did that is, even though I clicked buttons a lot more than twice, is I used sources and sinks to do all of the updating of that panel locally. But I pretended that adding 2 numbers was beyond the powers of JavaScript, just so that I could also show client-server interaction. And therefore, I made the round trip for that part alone, and not the other part, right? Because one would imagine instead of a button that adds 5 and 2, it says, give me a complicated statistical regression on some data set. And, well, obviously, you're going to rely on the server to do that. But then on the front end, you want to be able to sort of handle the GUI stuff without having to make a shit ton of round trips.
I'm still trying to grok the sort of overall principle behind this. Can you describe, just hand-waving style, in the interaction you just did, which state is on the browser and which state is on the server?
Well, I'm going to show you now the only 2 calls that were made to the server. And then I'm going to show you the code that generated this, which will be a bit more concrete. Right? Okay, there was no state on the server. Ever. All the state is on the client. The only question is, how often does the client tell the server, here's a computation I need you to perform for me. Here's enough state for you to perform that computation. That's the only question.
Well, I guess I'm trying to understand how well you've done at minimizing the state you have to ship back to the server.
When you show us the code, which kind of code indicates calling the server? How do we know when it happens?
The only time the server gets called is when you say on event. And then the event happens. And if you want to keep track of it, you look at how many times you call the callback here. So like I said, I clicked 12 things, so I called the callback twice. In this case, I called the callback with the information something with a funny name is 8, something else with a funny name is 5. Those are the 2 numbers we're adding. One of them we didn't see on the screen at the time. We kept it in sort of separate store on the page, like a hidden input, right? We like to keep everything actually physically on the page that's in memory. We don't have to do it, but that's the notion of the panels, is everything has a physical location, even if that location is sort of hidden. It lets you envision the dependency graph very intuitively. And then we set the information that we're adding them is one of these things. And then we set, and then we sent the information that the add button was clicked. And then there's probably a couple extra pieces of information we need to send here that I could do better at getting rid of. Oh, that's the full trace. That's a separate thing. I'm not going to go into why we need the second thing. We only sent the information we needed there. And then we sent this other thing, which deals with a very weird case. That means that I have to send more data back than I would like to handle the corner case. I'm not sending all the data back. I'm only sending some back. But you have to send back, and this is sort of a technicality, I don't want to dwell on this talk. You have to send back not only the data that corresponds to the things that this guy might depend on, but the data that corresponds to the path that will take you to that guy, right? Because we label each possible function we're going to call by sort of the tree path of data that took us to that function, and that, right, like its location in the tree in a sense, so to speak. But that's also the state of all the other data that generated that path. So you sort of have to capture this functional snapshot of time looking back a bit when you do callbacks, which is weird, and I don't want to dwell on it. It took me a while. It was a good week. But it really fixed the semantics. But it does mean that you're sending back more data than you might imagine. I will tell you that you can write things like this in ASP.NET that claim to sort of do this. And they actually have precisely the bug. They don't capture the path. And so if you have like an ASP.NET interactive panel that has another interactive panel inside of it, you can do things where you'll just totally screw up the state. Yep. So I solved that problem. And it does mean you carry a bit more information than you expected.
You said that the tree where you're talking about the path is the tree of dependencies. Can you explain? Can you map that to the concrete dependencies involved here?
The other one, it's a bit simpler. Right?
Not fully understanding your paradigm, I can't read it out of your code. So I'm looking for some.
Well, I'm saying in this version it's simpler than the calculator code that I haven't shown you yet.
Pick whichever one, but I can't read your code and understand this.
So you're saying the tree of dependencies.
You said that the labels that you're passing back and forth in the state refer to a tree, but it's not the DOM, it's...
Yeah.
I thought you said the dependencies.
Yes, precisely. So let me explain what I mean by that a bit better. Let me show you the generated code in this one, actually. This is going to look terrible, but I'm sorry, like at a certain point, maybe I could have, if I realized this was a question, I could have maybe tried to draw what a dependency tree is as a separate thing. But here I'm going to explain the code. This is all what we call the runtime system. So that's all the, oh no, this is still the calculator panel, sorry. Because I took this guy down, the server down. So the tree of dependencies, let's just talk about it, is, in this example here, right? This, in order to show the 2, 3, I have to be able to read from that to tell me about the 2, and this to tell me from the 3, right? So this depends on both of those.
And also click me?
No, it doesn't depend on click me. It's just listening to the event. You can't depend on an event.
Okay.
You can just depend on a signal. So that's what a tree of dependencies is. This depends on that, right? If I change this, and then I refresh I redraw this part because I read an event, this needs to care about that. So the tree of dependencies is, if I change this and I had some other guy over here that never called select on that signal, or with signal on that signal.
Yes, with sample.
With sample, that never called with sample. So if I had something over here that never read from this, and it was just appended over here, it would never get updated. If this generated some other information, that information would never get sent if I was refreshing just this part of the page. It would be ignored. But if I have but you can think of this not as just existing as a DOM on a page, but as that model of I'm proceeding along the computation, and I've actually called in the code a function that says, give me a select, right? Now, after that, I've called read from the select, and then I've called something else. So you can actually map the tree of dependencies to lexical scope, right? All the variables that are in lexical scope that have been read from the environment are the dependencies, right? Does that make sense? I depend on potentially everything in scope. And so that's actually very nice, just like RAII in C++, the acquisition and initialization thing. It gives you a model for how to think about memory usage by thinking in terms of lexical scope. I can look at what's in lexical scope at any moment in my Haskell program, and that will tell me what things I may or may not depend on.
much of the weird black hole NVAR thing?
The black hole NVAR thing fucks all that up.
Okay.
Yeah.
So if you're sending back the path, does that mean that you're sending back everything in lexical scope?
No.
But then I'm not following the relationship between the different.
Yes, actually, yes and no. I'm not sending. Wait, when you say lexical scope, I'm saying if I need to update this,
Yes.
I'm sending back this and that because they're both in lexical scope. If I had a third thing that I actually selected from,
But there was that last parameter where you said you fixed the problem, you added this path, that was everything that you were dependent on. Is that everything in lexical scope for one of these things?
no,
Then what?
that is the same tree of dependencies that got us there, but it's the tree of dependencies as of when this when the code was generated, which is sort of a different story. But yeah, I mean, it's potentially more stuff, yes. But again, what's in lexical scope is only the stuff you've selected from. If I have a signal lying around, it doesn't matter. It's only if I've sampled from the signal that the actual variable that I pulled out of it then invokes a dependency relationship.
So on event is the only construct you use that causes a call to the server.
Yes.
Should I think of the continuation passed on event as effectively being allocated on the server, like in the other continuation-based frameworks you talked about, but there's a static guarantee that there are a fixed number of those continuations?
No, because what exists on the server is just this piece of code that I showed you. There's nothing else. It doesn't have like a table to index into. It just sort of generates that on the fly.
I see. So the request you send gives you a path through that piece of code to find
Yeah.
the event handler.
So it's a lot like sort of Ackar's incremental computation, if you know that stuff. That's more the model. It's sort of an incrementally computed sort of reflexive web page.
It's if you think about just the API, the Haskell code. There's no actual state in the Haskell code because you have these events and you have signals and there's no streaminess to them. They're just
You can sample them, but
you can sample them, but
they're
you can't,
conceptually.
you can't compute like a moving average.
Yes.
So on the Haskell side, there's no running state. You could think of it on the Haskell side as really it's a pure function from all your selectors on the page to HTML. And so clearly, since you just have a pure function from selector state to HTML, there's you can just call that pure function as many times as you want, and you don't really need to do anything fancy on the server. I guess the only fancy thing is making it's like creating or compiling that pure function to a form, or not really compiling.
No. The only cost you pay is like if you have a really deeply nested thing of this, then maybe it'll take a long time to traverse each time. So if you write really perverse code, right, that's got and you have a dependency tree that is 100 things deep. Well, now you got to deserialize 100 things. That's sort of miserable. There are models it's not going to hit perfectly.
Yeah, we basically turn this thing into sort of the sort of applicative / sort of CPS sort of model in the back end that is has two interpreters: how to draw the original page, and then given sort of a set of queries that things that you're interested in, go get me the panels that I need to.
Yeah. So one way to think about it maybe is that there's two models when you write a compiler of ways that you'll do intermediate forms, and one of them is the continuation passing style, and the other one is what they call a normal form, right? And a normal form is related to what we call defunctionalization, where you take all the higher order functions and you turn them into these first order labels instead. So there's a model of doing these things where you actually explicitly just, quote, firstify your entire program. So it has no higher order functions. And every function that gets exposed you sort of unwrap the entire graph and lay it flat on the table. And then the other way you do it is you just implicitly, through CPS, have that tree. And it can be demonstrated that there's an equivalency between the two sorts of approaches. And this sort is sort of an obvious, straightforward way that just lets you embed everything directly. But just like with compilers, sometimes if you take it to a normal form first, you can probably actually do a much better job at eking out every last drop of performance. My claim, though, is that, right, yeah, there's a lot, like I showed. I mean, the most obvious thing I do here is I do path compression, and so that 1_000000 is a bit shorter. I probably I wouldn't want to just use 1 and 0 because I'm using a string. I've got a whole lot more bytes I can use that way. Right? There's a million things you could do to sort of compress this data before you even start to talk about the more difficult things, if you start to hit that limit. But that hasn't been our experience, that's where the problems are. So. All right, let me show the calculator code. I showed that the calculator works. I'm pretty proud of that because that sort of, that, again, it's a good, sort of hello world, because if you can build a calculator, you can build most interactive things, right? No, I mean, it's true.
Just, write a TA.
It's because you've got circuits, you've got feedback, you've got to have a memory store, especially if you've actually tried to build one as much. You know what I mean? It's a good workout of all the basics of interactions. So here's the code directly, and I don't know, maybe I'll and this actually, I don't know if this actually shows any cute J macro code as well. Here we are. So I don't know if this is going to be. Oh, this is way at the top here. This is the quote prelude or runtime system, as they call it. And I'm just going to show you it because it'll show you what J macro looks like. Right, so this is all JavaScript written inside Haskell somewhere. That's just Haskell and Haskell. This is JavaScript in Haskell, where you can say fun, this, and then you can do the brace syntax, or you can do variables. So it looks a lot like JavaScript, but it's slightly lighter weight syntax. You can use / for lambda, which might be used in some places. This is what manages all the dependencies, if we wanted to deep dive on that.
So right now you're showing us part of the implementation of your library.
Yeah, and it's written in JavaScript, except it's in J macro. So it's in a sort of dialect of JavaScript that's embedded inside Haskell. And this all gets sent back to the client. So this is what I call the runtime system of the library.
The typing of J macro is JavaScript? Nothing?
Yeah, there's a partial implementation of a type checker, but it turns out that typing JavaScript is hard. So.
That was actually the piece that Lauter wanted to rip out. That's one of the reasons why he did his thing, because he could go a little bit faster without some of those syntax trees and whatnot.
Yeah, right. Okay. But I don't carry around the types, so I don't know why he'd care. It just keeps an open hole for them unless you actually elaborate. Anyway.
Did you say that you changed the variable scoping rules in JavaScript?
Yeah, for example, if you have an if block in JavaScript, that's not block scoped. Right. A variable declared inside an if or a while loop actually gets lifted to the top level, which is disgusting. So in J macro, we don't do that. We use an extra closure to make sure that it lives in the scope it's supposed to live in.
You could use that.
Yeah. You could tie yourself to Mozilla, right?
No, you could insert function, nested functions in order to have the lens to a more compatible way. You could.
Yeah, but I don't. I do this. Anyway, so that's just to show you a flavor of it's not a lot better than JavaScript, but especially if you're doing higher order functions, the conveniences tend to add up. And here I'm not doing any real generation. It just happens to be I wrote this stuff in JavaScript. And some of this other stuff I actually generate. Anyway, here's a calculator. Sorry. So we declare a text pane. We declare new var, right? These are like mvars, right? So they have a source and a sink pair both. So we get a store signal and a store input. And here the command store signal and the command store input, right? Because we need to store the plus sign and we need to store the number. That's sort of in our, the one we're adding to. I declare this function in inline.js, so this is J macro, but so lambda x. So this is inline JavaScript. And the reason I'm going to do that is I'm going to apply that in JavaScript so that I'm going to conformat, not in Haskell, but in JavaScript, that whenever I add something to a display, I'm going to trim it, and then I'm going to sample in JavaScript the display signal so I don't have to make a round trip. And then I'm going to add what I had before to that, so that each time I add a number, it goes to the end. And if there's any leading zeros, they get trimmed off of it. So this is all happening in JavaScript. And that's the nice part about that. Now, it's true that it's not as nice as if it was all in one language, but the impedance mismatch between swapping between Haskell and JavaScript here is not nearly as bad as if they had to live in entirely different files or something. And especially if you're just writing small helper functions like this. Now you have buttons for numbers, for operations, right? And here these are functions that generate the buttons, right? So it says, give me a number, and I will give you back a button that has that number. Give me an operation, I will give you back a button that has this operation. And when that button is clicked, it will perform that operation. So you're going to give me the function as well. And then we have a clear the memory button that will just, shove like all the default values back into our stores here. And then the equals button is going to say, read me all the different stuff, sample all this different stuff, and then execute whatever the operation was that I've read out of there, right? And it just turns the strings back into real operations. And then I stick them all in a table and I'm done. So I think that's a very declarative description of a calculator. And it has that circuit feel where it's like, well, if I do this, it sticks this in a store and, clears out the input again. And if I click that, it reads from the store and reads from the input and ops them together. And I think it's sort of a proof that this works pretty nicely. And, if you pretend these are expensive operations, but clicking, the numbers is cheap, then it lets you distribute work as you feel between the client and the server pretty seamlessly and choose where the computation happens depending on what makes sense.
So somewhere in here you have code that says when one of the number buttons gets pressed, do some JavaScript, right? Where is that exactly?
Actually, I don't.
Okay.
So what happens is I call bind sig sync, which says the number button is going to be the constant signal of that number. And the sync is going to be the display input. And then the display input is going to be like, it's a tangible value, as Conal likes to say, right? So every time, so it's a pane that happens to display whatever its value is, and also happens to have an output lead that will let me read out what its value is back into my program. So I actually can, without declaring, actually update it, right? It's just like a calculator pane that you use a component if you're using electronic circuits. It just sort of accidentally displays you the number it happens to be storing. And that's how that's written. And so therefore, we don't need to listen on any of that stuff. Right. And we don't, and on the up, again, it just does binding. So we don't even have to listen on events for the most part. We throw them away. The only event we listen, or bind sig sync implicitly listens on the event, because it only does this thing when the event fires. But then we throw them away outside of it. And the only real event we listen on is the equals button that actually calls on event to actually perform the computation.
So how powerful is bind sig sync exactly?
That's where it does that's the tricky bit. That's the part where you can bind it in JavaScript if they're both JavaScript types, and then it'll never make the round trip. So on event always makes a round trip. Bind sig sync is the secret way to keep stuff in JavaScript land.
Yeah.
Or it can also do stuff if they're not in the right type. It can do it in Haskell land too. So it sort of has different semantics depending on it, which makes it a slightly cheaty functor, by the way. Because if I fmap it over something, it'll take it from JavaScript to Haskell because it doesn't know that it's it I fmap. So it's slightly it bends the functor laws quite drastically in order to get this cute behavior. Yeah.
What is the sample sig JS piece again?
So that's like sample signal, except instead of happening in Haskell, it happens in JavaScript. And it's a JavaScript function instead of a Haskell function. So it says...
So it's the same semantics as sample sig.
Well, it's not a continuation. In JavaScript, it's imperative. It just says, give me the current value of this. You just pass it a signal, and a signal has a meaning in Haskell and has a meaning in JavaScript. And you just pass it in, and it does the thing. All right, yeah, so that's my those are my two main examples, and we can go through other stuff. But I think I basically made my case here. I hope people sort of get it, that there's some non-trivial stuff going on. It does actually manage to do what I said on the box, is that you can have a fully interactive web application that really feels dynamic, does whatever the heck you want, and can scale out arbitrarily without having to worry about server-side state. And I think it's actually pretty easy to program with. I mean, obviously this isn't so pleasant, but how many calculators do you want to write in a client-server fashion? If you just want to stick HTML together and occasionally make it magically do stuff, it's very convenient, and you can start to build big libraries on top of it very easily and interop it with existing HTML and JavaScript really easily because it doesn't enforce any FFI. So yeah, thanks everyone for your time. It's a good workout, and I hope folks go check it out. I when I was getting this back running, there were some build errors with the latest ASIN. So it's on hackage. JMacro runs perfectly. It's used as part of HapStack as well as GHCJS, although maybe you didn't mind it. So it is widely used, very reliable. JMacro RPC is less used because I don't give enough sales pitches like this for it. So it's a bit rotted. I'm going to upload the patches to make it work with the latest ASIN over the next couple of days. But it's a lot of fun, and if you have a web app, maybe you'd like to give it a try.